Hi, I'm Phil Zimich from Comcast, and I wanted to take the time to walk through how we move from 962 nodes of Cassandra to 78 Scylla nodes for the X1 DVR platform. Hope you like what you see.
Anyway, so what I'm going to do is take the time here to take you through our implementation to Scylla. We started as a Cassandra, essentially house. That's where we live today, or we're living, and we're in the transition process now. So we'll walk through that and what that looks like. So a little bit about me. I joined Comcast, specifically the X1 team, almost 7 years ago. At the time, X1 was about 30,000 devices, so a lot smaller than today, where it's at. It's 31 million set-top boxes, and then a bunch of other second screen devices, phones, and whatnot. But funny story, like when I started, again, I joined from Lockheed Martin. I was looking to do something else, maybe some job that you could talk about a little bit, maybe my wife would understand. So I saw this job for X1, and I'm like, it looks cool, let me throw my hat in the ring, and I got it. I really had no experience with web development, didn't know anything about load testing or anything like that. The first role I had was, hey, come develop a load test. We're migrating to this Cassandra thing. I don't know what NoSQL is. We used Oracle. So I'm like, all right, cool, like we'll do that. So we're learning the API set. I'm brand new, it's a new thing. And about 6 weeks in, we have this outage. Our Oracle database goes down. There's no one on the team that can get it back going. It wasn't about like the skill set. It was just falling over time, which is one of the drivers for moving to Cassandra. So after about 24 hours of trying to get it back up and running, there's this decision made between like our president of technology and all his like direct reports. We're going to migrate to Cassandra tonight. They're like, oh, is your load test good? I'm like, well, I don't know. I think so. We're getting some data, like we're learning. So we migrate overnight. It's like a 48-hour outage. I go home on Friday, and I'm telling my wife, I'm like, I made a huge mistake. This whole department's going to be canned. We're done. I'm so wrong. I had a good thing going. But regardless, we weren't canned. The reason I tell the story is like twofold, right? We're at a NoSQL conference, and this is a database story, and a good one for NoSQL. And other is that Comcast is looking to push like the envelope from a technology perspective. If you look at what they did, this was what, 2013, I guess. They jumped into Cassandra, which was relatively new. At the time, Cassandra was like a newer technology. Our use case was definitely new to that technology. We did a lot of work with the Cassandra enterprise team to learn, and they were learning a lot from our use case and how we use the system. So Comcast is really like invested. When people think of it, they often think like cable company, integrator, but really, they're trying to move the ball from a technology perspective, and they're really trying to kind of advance and become a new like tech-forward company. So this is a little bit of who we are. I originally started this slide by, I'm going to throw up all of our subsidiaries. That became so scrambled that I'm like, I need to cut it down. This is probably about, I don't know, 30% of the companies that Comcast interfaces with, but they're the significant companies within my footprint, which is the X1 and residential. So our residential solutions is what a lot of people think of when they think of Comcast. When people sometimes complain to me about Comcast, oh, you work at Comcast, let me tell you about it. And I love that, and you're all welcome to tell me about Comcast. And I am really open to hearing it, and we're trying to make a lot of changes there. But along with X1, we have Xfinity Internet, Voice, and Home. So those are kind of the portfolio that we're offering from a residential perspective. So the X1 platform, specifically where we work, is a cloud-based solution. Again, I mentioned before, we have grown from 30,000 devices to well over 31 million. So it's been pretty substantial growth over that time. And it was a huge departure from the way Comcast did business before. So previously, and generally in the cable and set-top box industry, It's a firmware push down to the box. All the logic exists there. It's hard to do a lot of changes quickly because firmware pushes have some risk involved. It's hard to back them out. But X1 kind of changed that. So what it gave us the ability to do is just to roll out release fast. We roll out to a small percentage of customers. We're able to measure that, gauge the kind of level of operational success or failure, and roll back or roll forward accordingly. So there's a lot of data that helps us drive the platform forward, and we've learned a lot over the years. Additionally, X1 is also syndicated. So that's where we kind of step out of the residential space. It's been a growing area for us. So we are now syndicating to other cable MSOs. We're in many MSOs in Canada, Videotron, Rogers, Shaw. We also support Cox. So if anyone has an interface that looks like this, that's actually the X1 platform rebranded with the Cox, I think, Contour interface is what they call it. So I actually was at a friend's house, and they're like, oh, yeah, this Cox thing's awesome. Like, it's so cool. I'm like, that's ours. So it's pretty cool, right? So anyways, my space in the scheduler. Our scheduler system supports 15 million households. So 31 million devices, 15 million households. The difference there is that we operate on an account level. So when we scale things, when we're looking forward, account level is how we're kind of managing this stuff, because it doesn't really make sense to do a device level management for a household, right? You expect to see your recordings in your kitchen, in your living room, in your bedroom, or wherever the hell you have a TV. We are comprised of 20 different web services. Those web services primarily exist in EC2, and we're slowly stepping into Lambda. That's a new step for us this year, so we're slowly migrating more and more processing there. Our responsibility is essentially the DVR business logic for X1. So when I say that, what I mean is incorporating or understanding how to schedule what recordings when. So where we kind of fall in is we're the ones going out to see what's airing for a user. We then take that against and marry that to what the user wants to record, and we're creating these recording objects. Additionally, we are also responsible for all of the management APIs around that. So allowing users to see what recordings they have set, allowing them to change or to cancel a recording, that all falls under our domain. A little bit from our profile. We're serving 2.4 billion RESTful calls per day. That's across the footprint of X1 DVR specifically. And we're processing on 25 million independent schedule calculations. So that's when, again, that CPU-intensive process I just mentioned, marrying that business logic to what the user has requested, and then going out and creating these, what we'll call scheduler objects. So those scheduler objects, we're creating 200 million a day. That would include both recordings and reminders on the platform, even though recordings represents well over 90%. We do have a reminder footprint as well. And 55 million of those objects actually end up recording to the user. The discrepancy really is there's often times where if you look 14 days out in the future, we know that maybe Friends is on, but we don't know if it's new or repeat. It sounds kind of weird because it's Friends. But then eventually this stuff flows in that it's a repeat, so it all gets canceled as we flow down. From our database perspective, we are running 6 rings today with a total node count of 962 nodes. That node count is growing. We're essentially at our capacity from a Cassandra perspective. So if I were to display this slide tomorrow without any Scylla involved, we'd be well over 1,100 definitely by this time next year. From a total data perspective, we have 19 terabytes of data in 3 different DCs. So we generally run in 3 DCs, and the theory is n-1, we're OK. And that's kind of why our logic is as such. Here's our database use cases. If you look over this, DVR Prod 0 and DVR Prod 3, there are essentially our original databases when we started this 5-6 years ago. Over time, those databases have just become too large, and we've had to go and break them out. So the Prod 0 database was all the user data. So if you are on the X1 platform and you have recordings, it all existed. All that logic exists in Prod 0. prod 3 was used for back-end stuff on our side. When do we refresh your account? How do we decide when to run separate business logic rules around your account? So it was really back-end. History was a third database. So what we're doing is, I mentioned we create 200 objects a day. Every time that object changes status, we're going to log that into our DVR history ring. So you can imagine 200 million rows created per day. And that's basically 7 days a week with many updates. Typically, a recording will have, in a successful case, 3 updates, scheduled, deleted, and erased. In many use cases, though, you'll see send 10, 12, even 35. So that table gets pretty big pretty fast. DVR auxiliary and DVR instruction, they were actually breakouts from the prod 0 ring we did in 2018 to keep our node count down. That prod 0 ring was at 144 nodes per data center at the time, and it was a decision that it was pretty cumbersome, or is pretty cumbersome to manage at 144. Growing horizontally beyond that would just be insanity as far as management. So we decided to do some migrations to break them out. And our last ring we have up here is DVR reminder. The reminder ring is all of our reminder data. So we only have one ring for that. The advantage, what we kind of lean on there, is these things aren't durable beyond the start time, where recordings we may have to keep for up to a year. Once the reminder is fired, we can delete it and forget it. So it helps keep our data size down. So our Scylla evaluation, and I could really take a step back to set the kind of tone for my team. There's another team at Comcast. VJ presented here last year, if you were here. The group there was into Scylla last year. So we made a decision last year when they were moving to Scylla that we would evaluate MongoDB and Postgres while they did Scylla, and we kind of see how everything washes out. The MongoDB evaluation was really, really successful. We are using it today for certain areas of our application, especially around analytics. However, from a Scylla perspective, or from a recording perspective, it didn't really live up to what we needed, at least at the time. I think we could tune it if we wanted to, but the Scylla data was so promising from their experience and from the experience documented that we said, OK, we need to go here. With the logic being that because we're in Cassandra, we can get there really fast. We can save a ton of money. And most importantly, we can give a lot of performance back to the end user, which is like our main goal here. And we'll get into a little bit of what that looks like. So when we started, we took a sprint-by-sprint approach. Our first step in our process was to just get a Scylla ring up and running and run some stress tests and data on it. I wanted to prove out in our environment, in our EC2 space, that we saw the same numbers that the Scylla website was reporting and all these case studies were reporting. Not that I didn't trust it, but we want to see it work for ourselves. We've had issues in the past with Cassandra. So that was all successful, incredible. So we jumped into our data model. And it's like, based on our Cassandra experience, our data model sometimes causes issues or stress on the technology. For comparison purposes, we've gone through more data models since we've migrated than I can really count. I think we've gone through at minimum of 4, and we've tried 2 more that didn't work at all, so we never rolled them to production. So it's been a challenging space to kind of have something that works in the technology we're talking about. So we just plugged our existing data model in, and we ran essentially a time-based load test across the system. What we kind of did here was we leveraged ECS in Amazon and elastic scaling groups to make sure that there was no bottleneck between our load generators, our data services, and our Scylla. So essentially, we were trying to peg the Scylla database without leveraging anything in front. And what we saw was pretty phenomenal. We simulated 2.5 times our peak load on a single data center while seeing a 95% drop in our response times. So I mean, that's like value that you pay right back to the end user right away, right? Especially in our 99ths and like our 39s. Like that's really where our stress was with Cassandra. Our median times were okay. We could certainly live with them. They're not the best, but they're certainly not the worst. But it's when we get into those 39s and 49s where like our system started to fall over, and we do a lot of caching logic on the back end on the UI side to kind of mask that to the users. So this will allow us to actually rip that cache layer out, which will be a huge win as well. Additionally, if you look across, because I mentioned we run 3 data centers, this is really 7.5 times our load that we actually see in a production ring. So it's a massive, massive gain from where we are today. And really, really, it makes a lot of sense to jump forward. So our Scylla migration strategy was kind of to kind of balance a logic of we have these cost savings, we have performance gains, and we want to minimize risk. So the first thing we did was we tackled that recording history database. So there's 200 million new rows a day, many, many updates per row. So we said, let's migrate that over. We successfully did that very quickly, and we have been on recording history in Scylla since July. No going back. We decommed the Cassandra ring, and we're moving forward. We saw a 61% savings there, which is pretty massive. And it gave us the ability to do a couple other things. Since we're the clients, and when I say we're the clients, I mean my team, really. The scheduler team is the clients of the history database. We're also able to, in production, do some retests. So although this is a write-heavy load, we actually did a lot of reads in production to kind of simulate what does this look like actually in production. We know we have load tests, and we've been confident in our load tests. This load test approach we've took is brand new, though, is different, and has been more successful than anything we've done in the past. But can we validate it in production? So we're actually able to do that. It was successful, and we've been on that ever since. Recording data is in process now. So recording data is the biggest value here. So it has a little bit more risk, obviously, but it's the direct value back to the end user. These are calls that the end users are waiting on. These are calls that if you're in the X1 platform and you go to a recording list call and you see there's a little spin icon, but you can imagine an hourglass if you're not familiar. It's probably waiting on recording data history, and you're probably on our 3/9 or 4/9 call. So the sooner we get Scylla out, the sooner we eliminate that. You saw the numbers from the last slide. They're incredibly better than where we are today. So we're jumping there pretty fast, and we're trying to get on that to kind of eliminate all of that logic on that side. And again, from a savings perspective, this is actually where we see the most. It's 65%. From a dollar perspective, it's over $1 million annually. So it's a huge give back to the business, which is a give back to the, essentially it's how do we limit the cost of the product? Well, we can do it this way. We can do it in a number of ways, but this certainly helps. Next up, also in progress, is reminders. So from a reminders perspective, again, read heavy, also customer facing, so there's some risks there involved. But we're pretty confident in the ability to run forward with that, and we'll be able to yield a 41% savings there. And then finally, instruction and lookup. Have not started this one yet, so this one is in progress, but the great thing is each one becomes easier. So all the groundwork is now laid by the time we actually get to recording data. So recording data and reminders are going in parallel. Instruction will be last, probably Q1 of next year. We'll actually finalize it. But read-heavy workload, customer-facing in a sense that this data is powering your experience. However, you're not waiting on the responses, which is why we put recording data first. Recording data, you're actually waiting on that response. You see that 99th. Where in the instruction lookup, you're not really going to see it. You don't notice it. It's a background task that we do asynchronously, so it's not something you'll pick up on. And there's, again, a 54% savings there as we kind of roll it out and are done with it. So this is our kind of final Scylla impact and where we are and where we're going. So like I said, 962 nodes and growing. We are at capacity now. In the Scylla world, we'll be at 78. And the great thing about that is in 2022, unless something drastic happens, and I mean, we can double our footprint. I mean, unless we have 100 million customers, we'll still be at 78. So there's a lot of headroom there. We're not growing, so we're basically capping our spend here. As we add customers, I'm essentially making the platform cheaper. Every single new user, I make it that much cheaper. So there's a huge advantage to kind of get here, get going, and roll. Each ring, you can see it's kind of a breakout, and that's pretty much it from our experience. If you have any questions on this or on just what we're doing in Scylla in general, feel free to grab me, stop me in the hall. There's a lot of people here from Comcast. They work with Scylla more closely than I do, so I hope I can answer your question, but if I can't, I will certainly make the introduction to who can. And I do think it's helpful to hear how other people are using it as well, so I'd love to hear your stories. Thank you.